Hi, I'm Brian. I work at Microsoft. Worked at Microsoft for a couple months now. Really happy to be here in Bucharest. So yeah, I work for Microsoft. That's is Bit the raccoon, which is the mascot for the part of Microsoft that I work for, which is Azure. I'm on a podcast called Front-End Happy Hour, if you've never heard of that. It's a bunch of JavaScript developers getting drunk and talking about JavaScript. It's pretty fun. Sometimes I teach on a thing called Front Masters. That's usually what people recognize me from. I've done a bunch of courses on that. It's pretty fun. Used to work at LinkedIn for about 8 months, which was fun. Used to be an Ember and Java developer at LinkedIn. Before that, I was at Netflix. I was there for about 2.5 years. Worked on the non-member website, the TV, the Xbox, the Roku, all sorts of fun stuff. I used to work at Reddit, which was an adventure. Does anyone here use Reddit? Okay, some of you. The rest of you won't admit it, which is okay. I don't necessarily admit that either in public. I just moved to Seattle, or I'm rather in the process of moving to Seattle from San Francisco. I used to live in Salt Lake City, and I used to live in Torino as well, which is why I'm a huge Juventus fan. Though there's a different Juventus here in Bucharest, right? the one from Italy, that's the one that I cheer for. And this is my puppy. Usually they get people's attention, so that's why I put it up there. Her name's Luna. Okay, so how many of you in here are front-end developers? Just by like raising hands. JavaScript, CSS, HTML, Node developers too. How many of you are back-end developers? Okay. So you have no idea what you do. Okay, check. Designers, any designers here? What am I missing? Who didn't raise their hand? Somebody, okay. Well, I have been a front-end developer most of my career. I was a PHP developer once upon a time. And I wrote a lot of Node as well. That's mostly what I do these days is write more Node and React. Those are the kind of two things that I've specialized in. So, someone at a company that I'm not going to name, that's why I blacked out his name, the people who liked it, put this on there, and I don't really like this quote. I agree with the sentiment that not everyone is as fortunate as us that live in the developed world that we get to have fast internet connections, right? But if you go to some of these other places, like, thank you. If you go to like other places like India, China, and some of these places, you have really, really, really slow internet connections, right? And so I think that's the kind of point that this person is trying to make is that we as web developers are not necessarily catering to these developing countries, right? We're kind of catering to our own comforts, right? We're in offices with fast Wi-Fi and fast telephone connections and all that kind of stuff. So we're trying our best in. So like, got us some slack. Like I'm trying to put out a product, right? In fact, most of us are just trying to survive, right? We're trying to just get our product out the door because if you don't have a product, you don't make any money, and if you don't make any money, then you don't get paid. So most of us are just trying to make money and do the right thing. So not every app needs to work on 2G on a low-powered phone. You need to know what your audience is like, right? So for every one of your applications, every one of you should be very, very familiar with either the Google Analytics chart or the Omniture Analytics or whatever. You need to know how your users are looking at your websites, right? Are they using Internet Explorer 6, which I'm sorry if they are. I work at Microsoft, I can say that. Are they using the latest version of Chrome? Are they using old Android? Like, how are people interacting with your website? So that's why I have a problem with that previous tweet, this one here, is because not every website needs to work on 2G networks, right? That being said, I'm just going to talk about 2G networks today, so I'm sorry. So if you've never seen this chart before, I think this kind of blows people's minds. Is 2G is 14 kilobits per second, right? 3G, which is I think what most of us are used to. I've been on 3G most of the time I've been here in Bucharest. It's 144 kilobits. 4G is 100,000 kilobits per second. And then gigabit, which is what I have at my house in San Francisco, is 1,000,000 kilobits per second, right? So it doesn't matter how slow your website is. If I'm loading it at home in San Francisco, it's gonna load pretty fast, right? Hopefully your website is not a gigabyte. If you do, you have bigger problems. So how many of you had one of these? I did. Yeah, an old school 56K modem, right? Huh? This one actually, so this one's 56, but yeah, they had like an older version that was 28, and they had an older version of that was 14, right? So I had one of these growing up. My dad worked for IBM, so that's why I grew up around computers. 2G connections are slower than this, right? So imagine trying to browse the internet today using one of these. Imagine trying to stream Netflix with one of these. It's just not going, you're not gonna have a good time, I'll put it that way. It's gonna be pretty boring, because it's just gonna be buffering the entire time. So that's how you kind of have to frame these things, like how is my website gonna load if it's on dial-up? So yeah, 2G is slower than a 56K modem, which is crazy. For me, it's just crazy to think about because I'm never on 2G. And back then, when everyone was on that speed, websites were designed to be loaded on these really, really slow connections. Now that a lot of the world has much faster internet connections, websites like Netflix, like LinkedIn, like these bigger company websites are designed to be run on these really, really fast internet connections, which means that India and some of these other places are being left behind, which is not fair, and it's also, you are limiting how much money you can make, right? If people in India can't access your website, I'm picking on India, but this could be anywhere, right? This could be in Indonesia, this could be in Fiji, this could be in Alabama in the United States, right? Like there are places in the US that don't have very fast internet connections as well. And I'm sure around Romania as well, there are places that don't have very fast internet connections, right? So these websites are designed to be loaded on fast internet connections, and then when people from other parts of the world try and access it, they just can't. They can't access it. So this is the website I used to work on, which is LinkedIn.com. I'm going to show you what it's like to load LinkedIn.com on 2G networks. And I'm going to make you watch the whole thing. It's working. You can see the little thing spinning at the top. So grab a drink, make yourself comfortable, maybe take a nap, and I'll see you back here in about 10 minutes. No, I'm just kidding. It's not that bad, but it's pretty close. So how far? We're 20 seconds into this. There's still nothing on the screen. Nothing. Nothing on the screen whatsoever. 28 seconds. Oh, now we got something coming, right? This is, like, I take credit for this. Credit. This is my shame. This is what I used to work on, and this is how slow it is. So we're about 38 seconds in, and we're finally starting to see something on the page. How many of you would have just clicked, like, gone somewhere else at this point? Yeah, me, definitely me, right? This is insane. We're about a minute now. Still not loaded. Still not totally loaded. 1.2 minutes. And there. Now we're loaded. This took about a minute and 20 seconds to load everything, which just basically means that no one has stayed, right? You're going to have like a 95% drop off at this point. It's absolutely ridiculous. So this is a huge company. It's part of Microsoft, right? I still work at Microsoft. This is a huge company with 500 engineers, and this is the best that we can come up with. Like, it's not good. Now, to be honest with you, most people are not browsing on their desktop on 2G, right? Like that, those usually don't go good. They're usually on like a Android app, or there's like a light version of the website that you can use as well. So this is, I'm showing you this for effect, right? Most people don't actually see this. But what I do want to show you is, this is a different website, Tribo.com, which I've never used it before, but it's a website in India to book hotels, right? So let's see how fast this loads on the exact same internet speed. So we saw in 3 seconds, it had already its first paint, and within 10, 12 seconds, it's done. Like, that is insane, right? This is crazy, right? Like, this is a company in India, and they just kicked LinkedIn's ass, just up and down, right? It's not even close. Unbelievable. This is fantastic, fantastic engineering. So if this is a competition, Bangalore is definitely kicking Silicon Valley's ass, just out of the park, which is just unbelievable, unbelievable to me. Okay, so now hopefully you feel sufficiently bad about your website. That's what I'm going to, is just trying to make you feel shame inside of yourself, just like I do. So what do I do, right? I have no idea what I'm doing. That's how I feel most of the time. It's just like I'm floating through space, having no idea what I'm doing. What I'm going to do here is I'm going to give you a bunch of tips and tricks and ideas that you can take home to your applications and your side projects to help you find ways to speed up your website, because there's 10,000 ways that you can do it, and most of them are not so difficult. So just by raising hands, who here is using Webpack to build their JavaScript application? Okay, about a third of you, maybe? Babel, how many of you are using Babel? Just 2 of you. Okay, 3. I saw 3. Okay, well, maybe this might not be so applicable to you, but these are amazing technologies, and there are things that you should consider using. So the first thing I wanted to bring up here is you need to question your framework. Now, many of you are probably already working on large projects. Migrating frameworks is probably not in the cards today, but when you start a new project, I want you to think about everything that you're asking for, right? So here I have 5 of the most popular frameworks, right? It's not all of them, it's not meant to be all of them. But I wanted to show you that Preact, which is my favorite for probably reasons that are obvious that you can see in front of you, is 3.5 kilobytes, which means that it takes 0.1 second on 2G to load just the framework. Nothing else, it's just the framework. It takes 0.1 seconds to load that. Compare that to Ember, which just to load Ember, and not your application or anything else, but just to load core Ember, I checked this morning, takes 4.81 seconds. So just by using Ember, you're already adopting 4.81 seconds into your page load. Now, for most people, that should be unacceptable, right? That should just be a non-starter. But it depends on what you're doing, right? So sometimes you don't need your website to load in India, and so Ember is an okay thing. And so Vue, React, and Angular are kind of, in between all those. Now, what I will say is they're getting better. React used to be 44, and with React 16, they're down to 30, and it's getting better. The brand new Angular Ivy, which I'll talk about later, is actually down about React. It's about 3 kilobytes to load the new version of Angular, which is really, really cool. But yeah, well, I'll talk about that here in just a second. So, most people, when they start doing Babel, they'll use this, I can show you. They'll use this Babel preset ES 2015. That's really common. What it does is it takes all of your JavaScript. You can write futuristic JavaScript using arrow functions and all like the brand new syntax of JavaScript, and you can transpile that to something that will work in IE6, right? Internet Explorer and beyond. So most people don't even think about it. They just drop in Babel preset ES 2015. That's what they did for years. Last year, they came out with this thing called Babel preset env, this one down here. And what this one does is you just give it a target. You say, transpile this so this works for 95% of my users, right? And you just kind of identify which users you want it to work for and what preset env is it'll keep transpiling less and less of your application as more and more of your users are adopting newer and newer browsers, right? So if most of your users are using brand new Chrome or brand new Firefox, you don't need to transpile your code to work in Internet Explorer, right? Likewise, as the browser starts supporting more and more of these features, like arrow functions and generators and all these kind of things, you can stop transpiling your code to work for these older browsers. And so preset_env just does that for you automatically. You don't have to change anything. Just as time goes on, it'll transpile less and less of your code. So that's why preset_env is preferred to ES 2015. ES 2015 will always transpile everything all the time, and you get this large chunk of code, which is not necessarily ideal, right? You want just the bare minimum because that's going to be faster and it's going to be smaller, which is what we're going for, right? Smaller and faster. So this is a really, really new technique. This maybe started I don't know, maybe 2 months ago, 3 months ago. There's this script tag, this one right here, script type equals module. Have you seen this before? You can basically include ES modules, so like import something from something, right? And you don't have to actually bundle your code together using Webpack. The browser actually can understand modules natively. So if your browser supports this type equals module, that means it supports a lot of other functionality in JavaScript, right? So what you can do is you can put this script tag first, type equals module, and if the browser understands type equals module, it'll download this one, right? Which is really cool because that means you don't have to transpile very much of it. You can leave most of it just untranspiled. Now for browsers that don't support modules, you put this underneath it, this one right here, compiled with all the transformations, and this will get downloaded for older browsers, right? So you actually bundle your code twice. Once with this ES module is true, this is what you give to preset_env, the one that we were talking about previously, and you give this ES module is false to transpile both of these, right? So the browser's only going to download the one that it understands. So it's either going to understand this type equals module one, it'll download the smaller one, or if it doesn't, it will download this one. There's some cool blog posts from Google on how to do just this. So this is another really cool technique to make it really fast for people with modern browsers and make it still work for people with old browsers, right? Tree shake. So this is a really, really cool technique. The tree shaking is also known as live code inclusion, which is different from dead code elimination. That seems kind of counterintuitive. That sounds like the same thing, right? But with live code inclusion, you're only including code that could potentially ever be run, right? And with dead code elimination, you're going through and eliminating things that will never run. So live code inclusion will always be smaller than dead code elimination. So that's why tree shaking, which I don't understand why they call it tree shaking, that makes no sense to me, but some computer scientists sometimes called it that. Is going to go through your code, it's going to analyze all of your packages that you're including, and it's going to eliminate all the things that you never call. So let me give you an example of that. How many of you have used Lodash before? Or underscore? Yeah, most of us, right? It's like the standard library for JavaScript, pretty much. So if you do this, just this code by itself, that is 73.3 kilobytes. Lodash is a pretty big library. There's like 200 or 300 methods in it, right? How many of you think that you're using every method in Lodash? Literally no one. I don't think even the creators know all of the methods that are in Lodash. There's just too much there. So it makes no sense for us to be including everything, right? So when you come up here and say require everything, you're just getting everything from the whole package. So enter the new type of modules. So this is actually how you configure env, which is one that we were talking about. You say configure or transpile this. This works in the last 2 versions of Chrome, the last 2 versions of Safari, the last 2 versions of Firefox, et cetera, right? And they tell it, don't transpile the modules, let Webpack take care of that. So now Babel will leave those alone. That's one that's important, the module is false. So now what I can do up here is I can import from Lodash-ES, which is the ECMAScript version, right? It's the one that can be tree shook, and you get just the one method that you need, right? So here I'm going to call get, works exactly the same way, but now this is 11.1 kilobytes instead of 73.3, right? Because you're eliminating all of that dead code that you didn't need, right? Which is, in my opinion, quite cool. So just to show you what that looks like, this is called the Webpack module visualizer. So you can actually see all of the things that are getting included. So if you look over there, this part right here, this is all the code that I wrote. And this is everything that you need to import Lodash, just the get function, right? So this is the smaller one, the 11 kilobyte one. It's still a lot of stuff, but even still, that's only like maybe 10 kilobytes worth of stuff. If you include everything, it looks like this, which is crazy, right? You can't even read it because there's just so many methods being included here, right? So like you look there, like the object ones, the whole app, the string ones, like there's just a bunch of stuff that you'll never, ever, ever need. So this is why tree shaking is really good for you, because it's going to go through all of your modules and eliminate all the stuff that you're not using, which is pretty cool. But again, just to highlight for you, you have to use the new type of modules, right? The import something from something, right? That's the new way of doing modules. The old way is this one right here. So the require Lodash. This is called CommonJS, and we're trying to move away from that now to get into the new ECMAScript modules. It's still kind of hard to do with Node. Node's kind of catching up. We're not exactly sure how it's going to work, so good luck, I guess. Cool. So tree shaking is no silver bullet. No? Okay. I thought it was funny. I think I'm funny. Just kidding. So it's not going to work on every package. So first of all, the author has to write it specifically so it works for that particular module. So for example, React, you can't tree shake anything out of React. There's two reasons for that. One, they didn't build it so you can tree shake anything out of it. And two, the React library actually uses everything, right? So if you call React to render something out, it's going to use every piece of code in there. So you can't eliminate anything because everything is being used, right? So that's why tree shaking is useful for something like Lodash, right? Which is a library full of various functions, but it's not useful for React. So that's why it might work for your application, it might help, it might not. The other thing is that you're probably using all of your own app code, right? Like hopefully you're not writing code that you're not using. So it's not going to really help your code. It's typically just going to help with the libraries that you include. So just be careful with tree shaking, in the sense that it's not, you might do a ton of work for not a lot of gain. You also might save 60 kilobytes, so it depends on what your application looks like. Use built-ins. So this one's quite new. I'm excited about it, so let's chat a second about this. So use built-ins. This is new to Babel 7, which is the latest version of Babel. I think it's just been released officially, so I think you can use this today. So what I want to talk about is, let's say we have this code right here. var a equals new promise. Okay? Babel wants to include what's called a polyfill, right? So that it can run promises in old browsers, right? Because old browsers don't understand promises. It's a relatively new thing as of 2015, so new-ish. If you're including ES 2015 transpilations, that means that it's going to include that promise polyfill even if you don't need it, which is a problem, right? If we don't have to include that polyfill, then we won't. So what this will do, this A right here, is if the environment doesn't support promises, then it's going to include just that polyfill, right? Just the one for promises. It's not going to include all of the polyfills, which is normally what you would get previous to this point. So you would get all the polyfills for generators, for promises, for maps, for sets, for all these various different things that you don't need. However, if your environment does support promises, then you're just going to get this, and you're not going to get any of the additional polyfills, right? So that's what this use built-in flag does for you. It's almost always a good idea to use this use built-ins. and you just put that in your Babel config, that top line. Use built-ins usage, right? So only include the polyfills that I actually need. Please don't include anything else. So really, really cool feature. Would definitely suggest using it. You can see here it works the same way for map, right? Right there. So cool stuff. Loose mode. I think I have a slide that explains this. Yeah. So what loose mode is, this is your Babel transformation. So let's take a look at this code here. You don't have to understand the code that's up there. Obviously, there's a lot of code. It doesn't particularly matter. This is for transpiling classes, right? We got classes with ES 2015 as well, which are like bastardization of how Java does classes, right? They're crappy classes. I don't particularly like them, but they're there. If sometimes we use them, it's okay. I'm not upset. Just a little bit. Okay, so classes interact with everything in JavaScript, right? Everything has to now understand how to interact with classes in various different capacities. The problem with this, that means there's a lot of edge cases of how classes can kind of go wrong, right? So that's what this code on the left does. This handles all of the edge cases. Now, most of those edge cases, you're never going to hit. 99.9% of us don't write code in such a way that most of this code actually is important, right? Like, we don't have to care about some of these prototype properties and et cetera and that kind of stuff, right? So that's what this is over here. This is called the loose mode transpilation, which means that make it work for almost everyone and don't include all of the crazy edge case stuff, right? So most of the time, you're okay to just say use loose mode and just go ahead and get the smaller bundle sizes from Babel. If you're doing really crazy stuff with classes, one, stop. Please stop doing that. And two, you can use this instead. So yeah, loose mode. That's the one that you want, I think. This is a kind of a one that I hope you're already doing, but I just want to give you a gentle reminder. When you're building your code for production using Webpack, please set the node environment to be production. A lot of libraries depend on this flag to understand my transpiling for development mode, so I'm going to give you nice error messages and source maps and all these kind of different things. And if you switch it to production mode, then you're going to get no error messages, no debugging tools. You're just going to get like the very smallest package, right? So infamously, Slack was including the development mode of React. The development mode of React is like 10 times larger, right? Because it has like really nice error messages. It has a bunch of tools for us as developers to be able to write React more effectively. So please, please, please bundle your code using production mode so you get the smaller bundle sizes. And it's free, right? Like all you have to do is set node-env equals production and you just get free performance, right? That's my favorite kind of optimization, is one I have to do no work for. So node-env equals production. That one's important. Code splitting. This one is a little bit more involved. It requires more thought, and it also makes your application more complicated. I think I have, nope, I don't. Okay, so the idea behind code splitting is that when you are loading your website, you don't need everything all at once, right? You need some bare minimum amount of code to get your app up and running, and then you'll load everything else later, right? So basically you have your critical code loaded first, it shows the user something, and then it downloads everything else it needs, right? So for example, that Trigo site that we were looking at is making very effective use of code splitting, right? Because what it loads first is the bare minimum. Here's the search bar, here's a couple buttons that you as the user can start thinking about how you want to interact with the website. Then in the background, it's loading all of the code to actually do animations, to load the next page, to everything that's below the fold, right? It loads all of that second. That's what code splitting is. So for example, when I land on the home page for LinkedIn, I don't need to load all the code for the profile page, which is exactly what it does, and that's why it's so goddamn slow. It's because it's actually loading the entire website. All the profile pages, all the search pages, all the job pages, that's all loaded on your very first page loaded, which is unnecessary. So code splitting allows you to load all that code later, right? So the name of this talk is 10 kilobytes or bust, right? The only way you're going to ever get underneath 10 kilobytes is by doing code splitting. Now, what's hard about this is it makes your application more complicated, right? Now you have to worry about like, have I loaded this code before you try and run it, which is always less fun, right? It's fun to just assume that everything works. So the way that you do code splitting is you use a function called import, or dynamic import. This used to be called require.ensure if you did it the old way, but now the new way of doing it is import. What import will do is it'll go out, it'll download all that code, and it gives you a promise. And then once the promise completes, then that code has been loaded, and then you're welcome to go ahead and continue doing whatever you're doing, right? So it's not too bad. Webpack makes it really nice. Anywhere that you call import, it just automatically splits the code right there. So there are several places you can split codes. The most obvious one is various routes, right? So if I'm on the home page, I don't need to load the profile page, right? So you can load those every single time that when a user clicks a route, you can just quickly load all the code in the background and then navigate to the new page. But there are other things that you can code split on as well. You can code split on things that are beneath the fold, right? You can load that after. You can code split on modals, right? So if there's some sort of, warning modal, you clicked the wrong thing or your validation didn't go through, you can code split there as well. So there are several places that you can code split that's not just routes. It's anything that can be loaded later, it doesn't have to be loaded up front. Source maps. This is one that I notice on a lot of websites, that they include all their source maps when they ship it to production, which is a terrible, very, very bad idea. Like, feel shame kind of bad. Source maps are a really useful tool. So if you're using something like Babel or CoffeeScript or Elm or any one of these compiled to JavaScript libraries, source maps are really useful. I'm sure you maybe used it with Sass or something like that as well. That it will tell you when you have a bug. You can actually go and look at the CoffeeScript that generated, or the JavaScript, or the Elm, or whatever, and you can actually see that in the console as opposed to just seeing the compiled JavaScript, which no one understands. So they're really useful for debugging, but if you ship them to production, they're huge. It's going to make your bundle size like 5 or 6 times larger. Like literally, if your bundle is like 100 kilobytes, it's going to make it like 600 kilobytes to include all of the source maps. So don't ship it to production. Make sure that if you are using source maps, that when you do node end equals production, right, like what I was talking about before, make sure you turn off source maps. Like this is the biggest optimization you can make for your bundle right now if you're messing this up. So just go make sure that you're not shipping source maps to production. I beg you. Scope hoisting. So this one's relatively new as well. That's the logo for a library called Rollup. Most of you probably don't have to use Rollup, but a lot of the libraries that you use do use Rollup. So for example, React is bundled for you using Rollup, which just takes all of the dependencies for React and puts them together for you so you don't have to do it yourself. It was written by a really smart guy named Rich Harris, who's written a bunch of other really cool stuff. And it pioneered this technique called scope hoisting, which I think I have some code here to show you how it works. I'll talk about that in a second. So what scope hoisting does, on the left you see, I'll show you right there, this code right here. This is historically how Webpack has worked. So I require some code, this helper function, right? And Webpack puts that inside of what we'll call a closure scope, right? And it'll invoke that function, it'll return, whatever, this helper function right here, and then I can use it down here. This is internally how Webpack works, right? It creates this global registry of all the various modules that you have, and then it puts them together in one file, and then it just loads them as you need them. That's fine. It's a fine way of doing it, but when you have 10,000 modules, which some of us do, have you ever looked at your node modules directory? There's a lot of modules in there. This gets slow when you have a lot of modules. And it's a lot of unnecessary code, right? This Webpack require method is everywhere. So this library called Rollup pioneered this idea of like, what happens if we just inline that function right there? So rather than having to do this require and create all these closure scopes, which can be expensive, especially when you do it a lot, we just have these available methods kind of in a global registry, and then you can just call it right there. Turns out it's a lot faster and a lot smaller. I think I have, yeah, right here. So Webpack got scope hoisting as well in version 3, and you can see here, this, I want to say this is the New York Times. Don't quote me on that, but I think that's what this guy works at. They went from 70 kilobytes to 37 kilobytes without doing anything. Just for free, using scope hoisting, it got that much smaller. As well as their page load got like a half-second knocked off of it. Really cool, right? And they didn't have to do any additional work, it just worked. So you use a plugin called module concatenation plugin. So that's what you actually have to include into Webpack to make it do this optimization for scope hoisting. Module concatenation. So that's another advanced technique that's worth looking into if you have a Webpack-based build. Cool stuff. Yeah, you can see there, they went from 306 kilobytes unminified, right, to 176. They cut almost half of their bundle off. That's not going to happen for everyone. It depends on how your code is structured, but it can be pretty significant. You can see down here at the bottom, their vendor one didn't get a lot smaller. It went from 676 to 673, so they didn't really see a lot in all of their various JavaScript packages, but they did with their app code. So they saw quite a bit. So, cool stuff. Image skeletons. So this is more perceived performance, right? Because web performance is half science and half art. Like you want your user to think that your website's fast, even if it's not fast. Which sounds kind of tricky, and it kind of is, but it's also really cool. So I wanted to show you this. Gatsby actually does this for free, which is a React-based blog. So you have this image here on the right. So like this is the Golden Gate Bridge in San Francisco. This is a woman in the sunset. And what this will do is it takes these images and it makes these are SVGs, right? So this is a full size, let's say it's, 500 kilobytes, it's a nice large photo. This one right here is gonna be like 10 at most. And this one here on the left, which is even smaller, is going to be like 1 kilobyte or something like that. So what you'll do is you'll load this one first right away because it's very fast. You can even just inline it. You don't even have to have it as a separate file. And so the user immediately sees something there. Like they see it's like, okay, this has like a vague shape that's, filling up space, and so it makes your website feel really snappy because things are immediately put in front of the user. If you remember when we were looking at the Treebo website, immediately it shows you a blurred background. In fact, I can probably just go back and show you because I think that's useful. I think it's this one. So right there, see the background is blurred, right? This is exactly the same technique, except they're using a really, really low quality JPEG right there, right? So that's going to be like a kilobyte JPEG where everything's just really blurry and then just make it really big, right? And it compresses really well because, I'll show you again. It compresses really well because it doesn't have very many colors. So this is called an image skeleton, and if you think about it, you are loading more code, right? Because now you have to load the skeleton and then the whole image, right? So you actually are making your website larger in terms of kilobytes being loaded, but just that makes it feel really fast because something is there, right? If you had to wait until now to load the image, it makes that website feel a lot slower. And if you go back to the LinkedIn site, I mean, you have to sit here and wait 30 seconds to see anything, which sucks. I'm not gonna make you watch it again. I don't wanna watch it again. So if you come back here, this is really cool. Yeah, you can see here. So this one is using 10 shapes, and this one's using 100 shapes to generate that. Like, this looks like a bridge, right? Like, people can see that, and they can see right away, it's like, okay, there's a bridge here. Or like this looks like a woman standing in front of a sunset, right? So they can start kind of visually processing your website and start making decisions about what they want to do. By the time they have actually like looked at the picture, read the text, then they'll have decided, it's like, okay, I want to click on this. By that point, hopefully your entire website will be interactive and you can start, doing things. So, and there are libraries that will do this for you automatically. Like, you don't have to like write these by hand. But I will show you, there's several ideas of how you can do this, right? Like, I think this one's really, really cool. So this one they actually did by hand, go and draw SVGs. But all of these SVGs are like maybe 10 kilobytes, 8 kilobytes, and then they load later those, the real pictures. But that feels really snappy, right? Like, you can see that like there's a deer there, there's mountains, there's someone standing on a sand dune, right? This one might be my favorite though. Right? So you can use SVGs together with animations to have it have this like really cool drawn-in effect. And these SVGs that they load before the whole like album art loads, again, maybe 10 kilobytes. And all you have to do is just set CSS animation on drawing the paths, and you get that. Really cool stuff. So image skeletons is something that I feel like we as front-end developers haven't really explored enough yet. So definitely something to look into. So here's a couple other options. At the very, very least, you should be drawing at least a box, right, where something is there. Something I've done a lot of in my career personally is just putting a placeholder image there. Like, if this is supposed to be a user avatar, you just throw up there like something that just people understand is like, okay, that's a place where the avatar goes. It's going to eventually load the avatar when something gets there. Solid colors work as well. You can just sample the image and see what the dominant color is and put that there. Or you can do the blur up, which is what we were just talking about with Treebo. So you can see down here, I'll post my slides online, but this Medium freecodecamp.org, go to this URL. I took all of this from that article. It's really, really good. It teaches you how to do all of these things, so you can do it yourself. So you can see here, using these SVGs, this initial page load can get a lot smaller, which is really cool. This is before where it includes all of the images and it inlines them all together. So your initial page load you can shave megabytes off of, which is pretty damn cool. Let's see, we'll come back to this. I got my slides out of order. So your initial page load, you should really try and aim to be under 10 kilobytes. Now, this isn't always possible depending on your framework, right? If you're using Angular React, you start at 30 kilobytes, and that's just the way it is, right? Only if you're using Preact or Svelte or one of these like micro frameworks are you able to get under 10. But 10 is a good place to aim for, or at the very, very least, 10 more kilobytes than your framework. Just enough of a skeleton to get your app up and loaded and loading the rest of the website progressively. So invest time and effort into your build. What I showed you right here, most of this can be done in a week's sprint of just sitting there and tuning your build. So time invested into your build usually pays dividends. So I invite all of you to go back and look at your products and spend some time looking into your build. Load no scripts and just the bare styles to get everything above the fold loading. That's what that Treebo site does really well. It loads a bunch of code. If you go back and look, it ends up loading 500 or 400 kilobytes worth of stuff eventually, but it's at the tail end, it's not up front. Use image skeletons, use code splitting to get only the code that you need up front and delay the rest until later. So those are some suggestions for you. How many of you work with serverless? Any of you? Okay, I'm going to give you some tips and tricks with serverless, but this also just applies to many things in general. If you want to check out serverless, I'm a big fan. It's part of my job to work on serverless. If you go down here to this website, ak.ms/boxed, you'll see how to get like a free trial with Microsoft Azure, which is a really cool way to use serverless. I'm a fan. So when we start talking more towards the server side, now we want to reduce time to first byte, right? So with front-end performance, you really care about time to first page, so the first that you see something, and then time to interactives. So the time that a user has to wait before they can click on anything. So now that we're talking about the server, we're going to talk about reducing time to first byte. So the server timings API is really, really cool. We use this a little bit at Netflix. So you can see here, this is in Chrome, right inside of Chrome DevTools. I can see here how much CPU it took, how much CPU time. I can see how long the MySQL queries took. I can see how long the file system lookup took, and how, like, if there was a cache hit, and how long it took to read from the cache, right? So you can send all this information down with all of your API requests, so that inside of Chrome DevTools, you can go look at it and say, hey, you know, backend developer, it looks like the cache lookup is taking twice as long as it should. It's like, what's wrong with the cache, right? Or we're getting a cache miss every single time. Why is that happening? So this is called the server timings API. This is more or less what it looks like. It's just a header that you send down with your request, with your API request or your front-end index.html or whatever. And that's just included. And then you can see it inside of Chrome. I also think Firefox reads from it now as well. So server timings API, definitely something that you should look into. It's invaluable to me. Again, make sure you only do it in development. You don't want to be sending these down because these headers, you know, it just makes your request larger, which you don't have to do in production. So you also don't want to let people know that you're using MySQL if you don't have to, right? Or those sorts of information. Compress your responses. This is kind of an embarrassing story. When I started at LinkedIn, I went in and I saw all the API responses were huge. They were like 75 kilobytes and things like that, which is insane. Your API responses should never ever be that big. So I went in and started poking around, and I eventually found out that they were not gzipping their API responses, which is insane, right? For 3 years, this product that people have been working on had never compressed their API responses. You always compress your API responses. There's literally no reason to not to. So you should definitely go check that. So this is an extreme example. Normally you don't go from 73 kilobytes to 241 bytes, but you can, right? If the API response zips really well, you can get really, really small. So definitely look into that. How much time do I have? I have 13 minutes. Brotli. How many of you have heard of Brotli before? It's a pretty new technology, so I'm not surprised that many of you haven't heard of it. So most of us are familiar with gzip, which is exactly what I was just talking about, right? It takes your, large text and it compresses it down to a very small size using zipping technology, right? Like zipping algorithms. There's a brand new way of doing it. I think Brotli was invented at Google, if I remember correctly. Not every browser supports it, except these days almost every browser supports it, but it's a more efficient way of zipping your website. So here you can see LinkedIn, when they switched to Brotli, they saw much better load times on desktop and mobile. So feed initial load times, yeah. Just by switching to Brotli. So like free web performance again. Just by switching to Brotli, the page loads faster. If we go back to this is the support chart for Brotli. So you can see here, IE11, none of the Internet Explorers support Brotli. That's unsurprising because we don't work on Internet Explorer at all anymore. But now Edge works on it. Safari even understands Brotli, which is really cool. That's brand new. The iOS Safari, which is a pain in the ass in my opinion, also supports it. So it's pretty well supported now. So you should definitely go check out and see if Brotli will work for whatever you're working on. Cold start. So how many of your Node applications have this kind of dependency graph? Hopefully not many. So the problem, particularly with serverless is the idea that you have functions that run, right? So I just write a function, then I upload it to Microsoft Cloud, and then whenever someone hits this API endpoint, it just runs the function. Serverless is just a dumb word for someone else's server. Like, that's really what it is, right? Just like the cloud is someone else's computer, serverless is someone else's server. So when you do serverless, it's loading these functions, but it'll dynamically spin up more and more functions if you start having a lot of traffic, right? And that's what's really nice about serverless, is that it scales for you. You don't have to manage the auto balancing or anything like that. You just upload your functions and it just hopefully works, right? The problem is that as you spin up more and more servers, it has to start up these new servers, right? So that's why this cold start kind of sucks. It sucks on AWS, it sucks on Azure, it sucks on all of the cloud providers. So what you can do is you can use a thing called Azure Function Pack, which in reality is just Webpack, with like a couple tiny modifications. But you can pre-pack your serverless functions so that it doesn't have to resolve these crazy dependency graphs. So that's really cool. If you're going to do serverless, particularly on Azure Functions, you should use Azure Function Pack. It's pretty cool. Cool. So those are my tips and tricks for serverless and for server stuff. I got a couple minutes left here. I just want to talk about futuristic cool stuff that's coming. So computers. Great. I talked to Henry Zhu. He's the core maintainer of Babel, and I was like, what kind of cool stuff is coming? So we were talking about loose mode before, right? What they're going to build into Babel, hopefully, is they're going to detect if you need loose mode or not and just automatically turn it on and off for you, which is pretty cool because then you don't have to experiment. They can just throw in the thing that works the most for you, which I thought is pretty cool. Ahead of time compilation, any of you Angular developers in here? Oh wow, that's more than I expected. How many of you write React? Less than I expected. Okay, that explains it. Any Ember developers? Oh cool, I can shit all over Ember, that's good. Just kidding, I'm kidding. Did I miss anything? Vue, how many of you use Vue? Okay, Vue is really cool too. One of my coworkers is on the core team, Sarah Drasner. She's really awesome. So Angular, I haven't been an Angular developer since I worked at Reddit. So it's changed a lot since I worked on it, but they have this thing called AOT, right? Which is really cool, but it also is kind of difficult. I'm sure I see some nodding heads. Yeah. But what it does is it does some ahead of time compilation for you, so it just reorganizes your application to be more effective, and you don't really have to do too much to get it to do that. So AOT is definitely something that's cool and getting cooler with Angular. Partial evaluation. This one just still blows my mind. Probably one of the coolest things that's coming out. It's something that the Big Blue social network is working on, and it's called Prepack. Really cool stuff. So what it actually does is it partially evaluates your code for you in advance. So if you see here, I have a function that returns hello and a function that says world, and then a set of variables we called hello plus space plus world. And what it will do is it will go actually evaluate that so that it just says s equals hello world. So this is all that gets sent down to the client. Like mind blown, right? Like super cool. Same thing here with the Fibonacci, right? So what it'll call Fibonacci of 23, it'll actually go and evaluate that, and that's all that gets sent down to the user. It's crazy, right? So they're working on that. They're actually trying to get this into Facebook. It works with React, so it'll actually pre-evaluate all of your React components, so it's just shipping markup, which is insane to me. It's prepack.io if you want to check out. It's really cool. Disappearing frameworks. I think we're going to see more and more of this. This is something Angular is really leaning into with Ivy, if you've heard of Ivy before. If not, again, you Angular developers should go check it out. Ivy is going to change the way that Angular is going to be written. So there's two frameworks that kind of pioneered this approach. One is called Svelte, who's written by the same person that wrote Rollup, which we talked about previously. So the basic idea is that you're going to write some component, right? And it's going to ship down just the markup and like the bare minimum JavaScript to make that component work, right? Now, why that's cool is that you don't ship the framework at all. right? The framework, it actually just becomes a compiler, it doesn't become a framework. And so you're only shipping the markup and the JavaScript needed to make that markup interactive. So that's the point of Svelte. Svelte has no framework, it has no runtime whatsoever. It actually just ships us a series of components. So Angular's working on this as well. It's called the Ivy project. And eventually what Angular and Ivy is going to do, it's going to generate web components for you. That you're just going to ship a bunch of web components down, and it's just going to work. It sounds magical. I think it is actually some sorcery of some sort. I'm not actually sure. So, very cool, something to keep your eye on as well. Binary bytecode. So the one there on the right, this one, this is Glimmer, which is the rendering engine for Ember. There is Glimmer 1 out right now, which you can use, but is not something necessarily that is going to be the same as Glimmer 2. So Glimmer 2 is about to come out. It's written at LinkedIn, which is why I know about it. And rather than shipping you JavaScript code, what they actually ship you is binary. So it's just zeros and ones, which, as you might imagine, compresses really, really well. So all of your templates are going to be binary. So it makes what you actually send down the wire very, very, very small. So it ships just a very tiny JavaScript virtual machine that can read bytecode, and it generates the templates based on these binary bytecodes. So it's almost done. It's more or less working at this point. And then Svelte, which is this one here on the left, they're investing into that right now to make Svelte even smaller. So that's cool as well. So there's you might have seen To Do in VC, where like they have a bunch of different frameworks that build these various frameworks in Hacker News clones. So I just wanted to show you some of these time to interactives based on these newer things that I was talking about. So Preact is still the fastest. You can get Preact to be time to interactive for an entire complete Hacker News clone in 1.92 seconds, which is insanely fast, right? Svelte's 2.5, React and React on 2.57. And Glimmer and Angular, they're still catching up, but they're going to be smaller and smaller as time goes on as well. So that's the future. Hopefully, the future can come soon enough, right? We can make our websites even faster. But yeah, thank you for coming. So again, if you want to check out some of these things, I'll put these slides out later. It'll be here on my Twitter, @HoltVT. And then this AKMS box, that's all the serverless stuff if you want to check that out as well. There's like an awesome free trial as well. So cool. Thank you.